Good morning, good afternoon, good evening to everyone. I welcome all of you to Cafe class today. And in Cafe class, we want to look at simultaneous equations in core mathematics for the day. Simultaneous equations in core mathematics. I know some of you might have heard of simultaneous equations before, but for the sake of my newcomers who are hearing of simultaneous equations for the first time, I would want to give a brief but important introduction about simultaneous equations. So when we say simultaneous equations, then we want to look at two or more equations occurring at the same time. When we say something is simultaneous, it means that the thing is happening at the same time. So two events happening at the same time are simultaneous. This is happening here. This is also happening over here. So in mathematics too, when we say simultaneous equations, we want to look at two equations which are happening at the same time. The emphasis is on the same time, and it should be two or more happening at the same time before we can call it simultaneous equations. Alright, so an example is I have two equations on the board. Equation 1 reads as x plus y is equal to 3, and equation 2 also reads as 2x plus y is equal to 5. Now, there are some methods of solving simultaneous equations. I know you know how to use a calculator to do that, but we are not looking at the calculator today. What if there is no calculator and you have to do it systematically? You have to do it manually for everyone to see. If you have to do it manually for everyone to see, then I'm going to recommend the three methods that we have for you. The first method has to do with the elimination method, the second one the substitution, and the last one the graphical method. They are not in any order. You can start with the graphical first, or whichever you are familiar with, then you work with that one. Alright, so I want to look at the elimination for now. Alright, so with the elimination method, we simply want to look at a situation where we are going to try our best to take out one of the variables in the question, so that we'll be left with either two or one variable to work with. If we have three variables in the question, we can try our best to take out one of the variables, leaving only two of the variables so that we can work with that one. If we have two of the variables as well, we can try our best and work with only one of the variable. That is by eliminating or by letting the other variable go. That is mathematically. You don't just do it anyhow, but there's a procedure that you need to follow depending on the type of equation that you have. And even under the elimination method, we have three types and how we go about them. Three types and then how we go about the three types. So the first type has to do with when our coefficients are the same. The coefficients of the variable we want to eliminate, if they are the same, there is a way of doing it. If they are not the same, then we have another way of working around it. So the type 1, we want to look at the ones that are the same. Alright. So with the type 1 equal coefficient, equal coefficient, then it simply means that the variable we want to eliminate is having the same coefficient in both equation 1 and equation 2, or in all the equations that we are going to work with. Example: from the two equations on the board, it is very clear that y has a coefficient of 2 in equation 1, and at the same time y has a coefficient of 2 in equation 2. So if you want to eliminate y in this situation, it is going to be very simple and straightforward. Since the coefficients are the same, we just need to either subtract the equations or add the two equations together. Either we subtract the two equations or we add the two equations, depending on the operation sign in front of the two coefficients we are working with. When we observe clearly, we can see that the operation in front of the coefficient of y in equation 1 is plus, and the same thing is in the equation 2. If the operations are the same, then it is advisable you subtract the two equations. But if the operations are different, then you have to add the two equations together in order to get the result that you want by eliminating the other variable. So in this case, since they are the same, I'm going to subtract one of the equations from the other. So in this case, I'm subtracting equation 1 from equation 2. Five minus 3, that should be giving us 2x. 2 minus 2, that's 0. So 0y is equal to 20 minus 64. Now we know any number plus 0 is the same number. So in this case, I'm going to have 2x is equal to 4. I divide 2 by 2. X now becomes 2. Now after getting x is equal to 2, I have to put the value of x into one of the equations so that I get the value of y as well. I'm putting the value of x is equal to 2 into equation 1 so that I can be able to get the value of y as well. Now 3 times 2, that is 6. I have to group like this. Anything without a variable should go to the other side, and the variable should be on one side as well. So I have x is equal to 2 and then y is equal to 5 in this case. Now what I'm going to do is not part of the normal calculation, but it is something that you have to do to be sure if what you are doing is the right thing or not. So I'm going to do a verification to see if what I'm doing is right or not. So I put x is equal to 2 and then y is equal to 5 into the first equation, which is the equation 1. Without the equal to sign, I put it in it to see if I'll get the same 16. So I have 3x plus 2y. X is equal to 2, y is equal to 5. 3 into bracket 2 plus 2 into bracket 5. 3 to 6, 2, 5, 10. 6 plus 10, that is 16, which reflects over here as well. So you can see this reflection as this. When you put x is equal to 2 and y is equal to 5 into 5x plus 2y2, you are going to get the same 20. which means that the value of x is 2 and the value of y is also 5 from our calculation, right? So if that is the case, I'm going to give you one example for you to do in your notes under the equal coefficients. If you get it right, hit me up in my DM and then show me the result that you got. So this is a question that I have for you. 5x minus 6y is equal to 31, and then 3x minus 6y is also equal to 3. So you solve it nicely and then you present your answer to me in my DM or under the comment section. Very, very important, under the comment section. All right. So I hope by now you have done this, okay? Now, the second type of elimination method I want us to look at is multiplication by a constant. So when we take the question carefully on the board, we have 4a plus 4b is equal to 36. Then also we have 6a minus 2b is equal to 22. Equation 1, equation 2. When we say multiplication by a constant, we can see clearly that 4 is a multiple of 2, or 2 is a factor of 4. So in this case, we say that the 2 over here has been multiplied by a constant to give us this 4. Or what we are going to do now is to multiply these 2 by a constant so that we can be able to get this 4. And then in this case, we are going to have 4, then the elimination will become very easy. So what do you think is the constant we are going to use? Yes, we are going to use 2 to multiply the whole of equation 2 so that we get here to be 4, and then we can now work them out nicely. Okay. So multiply equation 2 by 2. Multiply equation 2 by 2. Alright, so in multiplying equation 2 by 2, the 2 is going to multiply all the terms. If you get the 2 is going to multiply all the terms. So I have 2 by 6a minus 2 by 2b equals 2 by 22. 2 by 6, 12a, 2, 4b, 22 times 2, 44, equation 3. Now from equation 2, we have got equation 3. We can see clearly that equation 3 is having 4b, and then equation 1 is also having 4b. So now we are going to work with equation 3 and equation 1. Equation 3 and equation 1, leaving equation 2 out of the whole work now. The equation 2 is of course what gave us the equation 3. So we are leaving that one out and working with equation 1 and equation 3 in this particular situation. Alright. Now, like I said, when the operation signs in front of the coefficients of the variable you want to eliminate are not the same, just add the 2 and then you get the variable eliminated. As simple as that. 12 plus 4, that should give us 16. A minus 4 plus 4, that should give us 0b. 44 plus 36. That is going to give us 80, right? Now 16a is equal to 80. Divide through by 16, divide through by 16. A is now equal to 5. Since we know that 12 times 5 is 60, 12 times 30 is 65 in that order. So we are going to have 5 as the answer for A. Now we put back A is equal to 5 into, say, equation 1. I want to put it in equation 1. You can put it in equation 2, you get the same thing. So I have 4 into bracket 5 plus 4b is equal to 36. 4, 5, 20 plus 4b, 36. 4b is equal to 36 minus 20. 4b is equal to 16. Divide by 4, divide by 4. B is equal to 4. Now let's work something and see if we get an answer. Let's put A is equal to 5 and then B is equal to 4 into equation 1 and see if we get the same 36 over here. So verification. So I have 4A plus 4B, which is now 4 into bracket 5 plus 4 into bracket 6. 4, sorry. 4, 5, 20, 4, 4, 16. 20 plus 16, 36. So we have 36 over here too as the answer. So just like I did with the first one, I'm going to give you one example for you to try, and the multiplication by a constant. And then after that, we'll end over here for now. Thank you so much for staying with me till this time. God bless you. Please don't forget to subscribe to the channel. Alright, very soon we'll bring you more content, more mathematics content. Alright, thank you. Yes, so your assignment, you have 6m plus 2n is equal to 18, 5m plus 6n is equal to 28. So you can see something from here. Take your